ARRHENIUS theory of acid and base. Acid is a substance which produces hydrogen and gives rise to H+ ions in aqueous solution. Here HCl, when added in aqueous solution, it gives H+ ion and Cl- ion. Since HCl produce H+ ion, HCl is acid. One more example, weak acid, acetic acid, CH3COOH. When added in water, it gives H+ ion. Next, ARRHENIUS base. A base is a substance which produces OH- ion in aqueous solution. Example, strong base. NaOH, sodium hydroxide, is added in water. It gives a sodium ion and hydroxide ion. Here, due to the formation of OH- ion, the NaOH is known as base. The second example, ammonium hydroxide. Ammonium hydroxide, when you add in water, it gives ammonium ion NH4+ and hydroxide ion.
I am acid man. I am a proton donor.
I am base woman. I am a proton acceptor. What is this?
Acid is a substance that donates proton H+ to another substance. Here HCl is donating proton. Therefore HCl is an acid.
Base. Base is a substance that accepts a proton H+ from another substance. Here ammonia accept proton to form ammonium ion NH4+. Therefore ammonia is base according to LOWRY-BRONSTED theory.
Example of LOWRY-BRONSTED theory. Here HCl when react with ammonia, so what will happen here? HCl will going to donate proton to ammonia. So here this is a proton of HCl and it is donating the proton to ammonia NH3. So what will happen here? Here since HCl is donating the proton, therefore HCl is acting like a acid, and since here ammonia, since this ammonia is accepting the proton, this will act like a base. Okay, so this HCl since it is donated the proton, it will going to form a Cl minus, because H is removed and it is given to ammonia, therefore it will going to form a Cl minus. And since ammonia accept the proton, then it will going to form a NH4 plus. So NH3 and H is added, therefore it will going to form a ammonium ion. So here in reverse reaction, now in reverse reaction what will happen? This ammonia is donating the proton to Cl minus. Here ammonia is acting like a acid, LOWRY-BRONSTED acid, and Cl minus is acting like a LOWRY-BRONSTED base. So ammonia is a acid and Cl minus is a base. So in reverse reaction, ammonia is acid and Cl minus is base. So in above reaction, HCl and NH4 plus both are, since they both donated the proton, therefore they are acting like a acid. And here ammonia, NH3, okay, and Cl minus both are accepting the proton, therefore it is acting like a base. Conjugate acid. So what is conjugate acid? The species. So what is species? So you see, I am giving you one example. For assume NH4 plus is a species and this is formed. So how it is formed? So this ammonia has accept the ammonia is a base. So what is the definition? Species. The species is what? NH4, which is formed when base means ammonia is a base. and base, what a base is doing, accepting the proton. So ammonia will going to accept the proton. So it will accept the proton from what? HCl. So here this is donating the proton. So this ammonium ion is acting like a acid and it is known as conjugate acid. Next, what is conjugate base? So here the species. So what is the species here? Cl minus. I assume this Cl minus is a species which is formed. This see how the Cl minus is formed. When this HCl will donate the proton, then it will going to form Cl minus. So Cl minus is formed when acid. This is the acid HCl. So this HCl is an acid which is donating the proton. Okay. So this Cl minus is known as conjugate base. So what is conjugate acid base pair? HCl and Cl minus are the conjugate acid base pair, because the difference between this acid and base pair is the difference of one proton. Next, so this acid and this base, this is a conjugate acid base pair. Next, here ammonia ion, just see ammonium, and here you see ammonia ion. Ammonium and ammonium ion, there is a difference of one proton. Therefore, these two are conjugate acid base pair. Next, identify the conjugate acid base pair in the following example. So this is the example where acetic acid, that is CH3COOH, react with water molecule, reversible sign, to give acetate ion CH3CO minus plus H3O plus. Here acetic acid donates one proton to water molecule. So this acetic acid is a acid because it is donating the proton, and water is acting like a base because it is accepting the proton. So here after this since acetic acid has donated the proton, it will going to form acetate ion, okay, and hydronium ion. Okay, because water is accepting the proton, it form hydronium ion, and in reversible reaction what will happen, this hydronium ion will going to donate the proton to form a acetic acid. So here hydronium ion is acting like a conjugate acid because it is donating the proton, and CH3CO minus is accepting the proton, therefore it is acting like a conjugate base. So what is the question here? You have to find the conjugate acid base pair. Differ by what? One hydrogen atom. So if you see here, acetic acid, there is one acetic acid and acetate ion. What is the difference between these two? They have a difference of one proton. Therefore, this acetic acid and acetate ion is a conjugate acid base pair. And one more example, H2O and H3O. There is also one proton difference. Therefore, this is also H2O and H3O is also a conjugate acid base pair. So both are acting like a conjugate acid base pair. Okay, next example, HCl when react with water to give hydronium ion plus Cl minus. Same here also, here HCl is donating the proton to water molecule. So here HCl is acting like a acid and water is acting like a base because it accepted the proton. And this will result in, this HCl will result in the formation of what? Cl minus. Okay, and water is accepting the proton, therefore it is acting like a it will going to form a hydronium ion. In reversible sign, what will happen? This hydronium ion will going to donate the Cl minus to form HCl. So here H3O plus is acting like a acid because it is donating the proton, and here Cl minus is acting like a conjugate base because it is accepting the proton. So which are conjugate acid base pair? Conjugate acid base pair is what? Difference of one proton. If you see here, HCl has one proton and Cl minus do not have proton. Therefore, there is a difference of one proton. Therefore, here HCl and Cl minus. And one more example, H2O and H3O. There is a difference of one proton. Therefore, H2O and H3O pair are known as what? Conjugate acid base pair. Next example, ammonia react with water to give ammonium ion and hydroxide ion. Since the water is donating the proton, therefore water is acting like a acid, and ammonia is accepting the proton, therefore is acting like a base. Here NH4 is donating the proton to OH minus, because NH4 when donate the proton, it will going to form ammonia. Here ammonia is there, and OH will accept the proton to form water molecule. This is there. Okay. So since here ammonium ion is donating the proton, ammonia ion is acting like a conjugate acid, and OH minus is accepting the proton, therefore it is acting like a base. So this is conjugate base. Here ammonium and ammonia ion both have one proton difference, therefore ammonium and ammonium ion is a conjugate acid base pair, and water and OH minus is a conjugate acid base pair. Next example, acetic acid when react with HCl to give CH3COH2 plus Cl minus. Acetic acid when react with HCl to give what? CH3COH2O plus Cl minus. So here CH3COH is acting like a base. Why? Because HCl is donating the proton to acetic acid. So here acid, since the acid is donating the proton to acetic acid, therefore HCl is a acid, and in reverse reaction this CH3COH2 will going to donate the proton to Cl minus, therefore this is acting, CH3COH2 is acting like a conjugate acid and Cl minus is acting like a conjugate base because it is accepting the proton. In this acetic acid CH3COH and CH3COH2, there is a difference of one proton, therefore CH3COH and CH3COH2 is a conjugate acid base pair. And in this another example is HCl and Cl, there is a one proton difference, therefore HCl and Cl minus is a conjugate acid base pair. What is conjugate base of an acid? So what is the meaning of conjugate base? The species which is formed when acid donate a proton. So suppose I will take the one example. This is a sulfuric acid when react with water to give hydronium ion and HSO4 minus. So we have to find the conjugate base of an acid. To find this conjugate base, the species which is formed when acid donate a proton. So you know that this sulfuric acid is an acid, and after donating the proton to water molecule, this is forming a HSO4 minus. Therefore HSO4 is the species which is formed. This is known as what? Conjugate base. So HSO4 is acting like a conjugate base. HSO4 minus when react with water molecule, reversible sign H3O plus SO4 minus 2. Here HSO4 minus will going to donate one proton to water molecule, and since it is donating the proton, this HSO4 will act like a acid, and after donating the proton, SSO4 minus 2 will be going to form. So what is the definition? The species, this is the species which is acid donating the proton, and when the species is formed, that species is known as what? Conjugate base. So here SO4 minus 2 is a conjugate base. So what are conjugate base for the following Bronsted acid? So we will take the example HF, H2SO4, HCO3 minus. All are Bronsted acid, and we have to find its conjugate base. So to find this, so this is HF. Okay. So what is conjugate base? The conjugate base is the species which is formed. So what the species which is formed when acid donate a proton? The here HF is a acid. When it will going to donate the proton, the species will form, and that species is known as what? Conjugate base. So after removing H from HF, the remaining part will be what? F minus, and this F minus is known as what? Conjugate base. Next example, H2SO4. So from H2SO4, one H will remove. After removing one H, what is the remaining part? HSO4 minus, and this is a conjugate base. Next example, HCO3 minus. Same thing, we have to remove one H from H, and after removing, it will going to form a CO3 minus 2. How minus 2? Because hydrogen has donated one electron to carbon. Therefore carbon, there is a increase of one negative charge in CO3 minus. Already minus is there, one hydrogen give one electron, therefore total there is 2 electron extra, therefore CO3 minus 2, and this CO3 minus 2 is a conjugate base. So what are conjugate acid for the following Bronsted base? So here NH2 minus, NH3, CH3CO minus, all are what? Bronsted base. We have to find its conjugate acid. So example, NH2 minus. First see the definition of conjugate acid. What is conjugate acid? The species which is formed when base accept the proton. So here NH2 minus is a base, and when it accept the proton, the species will form. So what species will form? If NH2 minus accept the proton, it will going to form NH3, and this NH3 is a what? Conjugate acid. Next, same thing here, NH3 accept the proton, it will going to form what? NH4 plus. Therefore here NH4 plus, which is a species, is formed what? Conjugate acid. Next example, CH3CO minus. After accepting the proton, it will going to form what? CH3COH, and which is a conjugate acid.
Hey, I am Gian Lewis, born in year 1923. Today I will teach you my theory. Name is Lewis acid base theory. Are you ready?
I am acid man. I am a proton donor.
I am base woman. I am a proton acceptor. What is this?
This is my proton heart bomb. Do you like it?
No. Wait, I want to hit your head.
Oh no. Now I am invisible man. Calling my brother Lewis.
Hey, I am Lewis. What happened, lady?
This is my answer to your brother. And also this 2 lone pair electron is bonus for you. Since I am base woman, I am electron pair donor. Therefore call me Lewis base.
Since I had accepted your electron lone pair, I am Lewis acid. Acid, any species that accepts a share in an electron pair is called Lewis acid.
Base, any species that donates a share in an electron pair is called Lewis base.
When boron trifluoride react with ammonia. Here ammonia donates share an electron pair to boron trifluoride. Hence ammonia act as base by donating lone pair electrons. And boron trifluoride act as acid by accepting electron lone pair. This result in the formation of coordinate covalent bond between boron trifluoride and ammonia. Amphoteric nature of water. Water has ability to act as acid as well as base. Such behavior is known as amphoteric nature of water.
So here water can behave like an acid also, and as well as base also. How? See, here water can behave as an acid by donating a proton. So water can behave like an acid by donating the proton. Water can behave like a base also by accepting the proton. So we will take the one example so that we get clear about this concept. So
Amphoteric nature of water. Ammonia base. Oh, ammonia, base. Then water will going to behave as acid. Acid HCl. Oh, HCl, acid. Then water will going to behave as base.
as you can see in the animation, if the ammonia is there, ammonia is a base, as you know, so water will going to behave like a acid. And if acid is there, then the water will going to behave like a base. Okay, we will take one example. See.
Amphoteric nature of water. Water acting as acid towards ammonia. Here there is a beaker containing ammonia. in that we added ammonia to it. Here water donate proton to ammonia. Thus water here acting as acid. Here water donate proton to ammonia. Thus water acting as acid. Water acting as base towards HCl. Here beaker containing water and HCl. Here water accept proton from HCl. Thus water act as base here. In this reaction water accept proton from HCl. Thus water act as base here.
Dissociation constant of weak acid and weak base. So what is dissociation constant of a weak acid? Okay, so let us consider one weak acid. Example is HA. We are taking example as HA. Here you can see H is there, means it is a acid group. Okay, the dissociation of weak acid in water is represented by. So consider this is acid HA. So if you will showing the equilibrium sign, okay, to give what H plus ion and A minus ion. So the HA get dissociated to form H plus and A minus. Since it is not completely dissociated, what is the dissociation constant? So how much it has dissociated, that is represented by a letter Ka. So here applying the law of mass action to the above reaction, so what you can write Ka. What is Ka? K is known as dissociation constant of weak acid. So Ka is what? Dissociation constant of weak acid. And to write the formula, what you have to do is the product of the product. Product means multiplication of the product H plus and A minus concentration. So first what you have to do is you have to find the concentration of H plus and A minus and you have to multiply it. Okay, divide by what? HA concentration, that you have to write below. So what will be the formula? Ka equal to H plus into A minus bracket, square bracket, that is concentration sign, upon HA concentration. Concentration constant of weak acid is defined as what? As a equilibrium constant. This is equilibrium constant for the dissociation constant of weak acid. Weak acid is what? HA. So next topic is Ostwald dilution law for weak acid. Ostwald dilution law for weak acid, HA. Okay, this is the scientist Ostwald. So Ostwald dilution law for weak acid, this is the scientist. Right side you can see it is the image of Ostwald. Okay, consider 1 mole of weak acid HA. Consider 1 mole of weak acid HA in V decimeter cube of a solution. So what will be the reaction? How you will show the dissociation of HA? HA will going to get dissociate to give what? H plus and A minus ion. Okay, so initially what mole you have taken here is HA, you have taken 1 mole, and initially when the dissociation has not started, the concentration of H plus ion is 0 and A minus concentration is also 0. So you are considering initially the number of moles was HA was 1 and H plus was 0 and A minus was 0. Next, now number of moles at equilibrium. Equilibrium is what? Neither the concentration of HA is changing, neither the concentration of HA and A minus is changing when the equilibrium has attained. Means what? Some part of HA get dissociated. That some part is what? Alpha. So alpha is the degree of dissociation. Now what the alpha denotes? Alpha denotes the how much HA had dissociated and it attained the equilibrium. So out of 1 mole, some moles get dissociated. That some mole is what? Alpha. So 1 minus alpha. That some mole which get dissociated, it has formed what? That H plus and A minus. So that alpha part will be this one, alpha and A minus. Alpha is what? Alpha is the degree of dissociation of H plus ion, and A minus is the degree of dissociation of A minus. What is that? It means moles. Okay, number of moles. So concentration at equilibrium. So what is the formula of concentration? Concentration 1 mole per liter. So how much mole is there after attaining the equilibrium? What is the mole of HA? 1 minus alpha. So we will take 1 minus alpha here, and you will going to divide by what? Volume. So what the volume is there? V. We have taken the V decimeter. See, you can see here upside volume we have taken a V decimeter cube. So what is the concentration of HA? It is 1 minus alpha upon V. And what will be the concentration of H plus? Similar, you have to take the number of moles and you have to divide by volume. So we will take alpha here and we will divide with V. This alpha upon V represent the concentration of H plus ion. Next, same thing here also, A minus concentration is what? Alpha upon V. Next, so this we have done now. The next is what? Acid dissociation constant. That is, dissociation constant of acid is given by, we know the formula, we have seen in the previous slide, that Ka is equal to what? H plus product of the product, Ha plus and A minus concentration product upon Ha. So Ka is equal to, instead of H plus, what you will going to write here? See, here H plus, there what you will going to write? What is the concentration of H plus? Alpha upon V. So here you will write alpha upon V into, then C A minus. Instead of A minus, you will going to write alpha upon V. So here alpha upon V. Divide by what? What is Ha? Ha concentration is what? 1 minus alpha upon V. So here you will write 1 minus alpha upon V. Okay, next, this V will cancel. What is the remaining part here? 2 alpha is remaining here, so you will write alpha square V and this 1 minus alpha. Okay, next. So this is equation number 1. Equation C is equal to 1 minus V. So what is the meaning of this? More the dilution, lesser will be the concentration. Volume and dilution concentration relation is what? Inverse relation. More you dilute any solution, just like for example, if you take a salt and if you add more and more water, you are increasing the dilution, but the concentration of salt decreasing, it became less salty. Okay, so concentration decreases. So dilution increases, concentration decreases. If the dilution increases, concentration decreases. So inverse. So you can see 1 upon V. So instead of 1 upon V, you can write C. So formula will be what? Ka equal to alpha square 1 upon V will be what? C upon 1 minus alpha. This is equation 2. Next, for weak acid Ha, alpha is very small. The dissociation it is very less, because it is a weak acid. Ha part, very small amount number of moles of Ha get dissociated to form H plus and A minus. That means alpha value is very small. So it is very small. So what you can do is 1 minus alpha is alpha you can neglect here in the denominator part, and it will be what? 1 minus alpha is approximately equal to 1. Almost there is a very slight change in the concentration of Ha. So here the equation 1, first we will change this equation. So instead of 1 minus alpha, we will write here 1. So what will be the formula then? K equal to alpha square upon V, and 1 minus alpha got converted into 1. So 1 we are not writing here. So formula is what? Alpha square. So V will go here, so it will be K into V. So alpha square equal to K into V. Then the alpha is equal to root of K into V. Next, equation 2. How to change the equation 2? K equal to what? Alpha square C, and instead of 1 minus alpha you will write 1. So this will get cancelled. Then the C will go below the Ka, then the Ka upon C, then alpha is equal to root of Ka upon C. So what is the statement? Degree of dissociation of the weak acid is directly proportional to, this is the degree of dissociation which is directly proportional to what? The square root of, directly proportional to what? Square root of the dilution. V is called as dilution, and K is constant. So alpha is directly proportional to the square root of the dilution, and here the alpha and concentration is inversely, okay, and inversely proportional to the square root of the concentration. Okay. Ostwald dilution law for weak base. Consider 1 mole of weak base BOH dissolved in V decimeter cube of a solution. This is the 1 mole of BOH and dissolved in V decimeter cube of a solution. So what is the dissociation constant of weak base BOH in water is represented by? So BOH will going to dissociate to give B plus and OH minus. When you add BOH in water, it will get dissociated to form B plus and OH minus. What is the initial number of moles? Initially the number of moles which is taken is of BOH is 1 mole. So here you will write 1, and B plus and OH minus is not there because initially dissociation has not started. Initially we have taken BOH as 1 mole, okay, and B plus and OH minus is not formed, therefore it is a 0, okay, 0 moles. Then after some time the dissociation started, okay, so there must be some dissociation, some part of BOH will going to get dissociated, that some part is alpha. So alpha, what alpha denote? Alpha denote how much number of moles of BOH get dissociated to form B plus and OH minus. So number of moles at equilibrium. Now the equilibrium is attained. Now equilibrium is attained means what? Forward and backward is equal, and number of moles of B plus and OH minus and BOH is not changing. But it is attaining equilibrium. It has attained the equilibrium. So at that time when the equilibrium was there, how many moles of BOH was there and how many mole of B plus and OH minus is there? So it will be BOH number of moles is 1 minus alpha, means what? From 1 mole alpha part get dissociated, and that alpha formed what? Alpha number of moles what formed? B plus and OH minus. So, concentration at equilibrium. What is the meaning of concentration? Concentration means number of moles per unit volume. So what is the moles of BOH? BOH number of moles is 1 minus alpha. So we will take 1 minus alpha here and it will be divided with volume V. After here, alpha number of moles of B plus and it will get divided by V. Same thing for OH also. Alpha will be divided by V. So we have seen this reaction. So base dissociation constant is given by. So formula is what? Kb equal to B plus and OH minus upon BOH. So product of the product. So multiplication of the B plus and OH minus divided by what? BOH concentration. So instead of B plus concentration, what is the concentration of B plus? Alpha upon V. So instead of B plus you have to write B alpha upon V. And instead of OH minus we will write alpha upon V. So divide by what? The BOH concentration is 1 minus alpha upon V. Here we will write 1 minus alpha upon V. VV get cancelled. What is the remaining part? Alpha upon V bracket 1 minus alpha. This is equation number 1. But the concentration is what? C equal to 1 by V. So instead of 1 by V, we will write here C. Okay. So C. So formula will be what? Kb is equal to alpha square C, and below 1 by V we have written C. So remaining is 1 upon 1 minus alpha, and this is equation 2. Now we will change this. For weak acid HA, you know the alpha is very small, because weak acid alpha degree of dissociation is very small. So we will assume that the number of 1 mole is almost approximately 1 mole. There is very less dissociation take place. Almost it is same. Okay, so instead of 1 minus alpha, we will, in both the equation, instead of 1 minus alpha, we will write 1. Then the formula equation 1 will get reduced to alpha square upon V, and this will be 1. So K alpha square is equal to Kb into V. V will go here. So formula will be what? Alpha is equal to root of Kb into V. And what about equation 2? Equation 2 will get reduced to V equal to alpha square C. And below there will be 1. Then the alpha square is equal to C will go down. Alpha square is equal to Kb upon C. Therefore alpha is equal to root of Kb upon C. So degree of dissociation of a weak base is directly proportional to. So degree of dissociation is directly proportional to the square root of the dilution and inversely proportional to the square root of the concentration. So this is known as OSTWALD dilution law for weak base. Expression for ionic product of water. Define ionic product of water. So ionic product of water is defined as, so ionic product of water, so Kw represent the ionic product of water, is defined as, is equal to what? Product. Product means what? Multiplication of what? Molar concentration. Molar concentration is denoted by the symbol bracket, square bracket. So there are two square bracket. Molar concentration of what? Hydronium ion concentration, that is H3O plus, and hydroxide ion concentration OH minus. So this is OH minus at a specific temperature. So at specific temperature. Okay. So ionic product is defined as what? Product of the concentration of hydronium ion and hydroxide ion at specific temperature, because this value depends upon the temperature. If temperature change, Kw value will change. So we have to mention this temperature. So ionic product totally depend on temperature. So we have to specify also that at specific temperature. Okay, next, see, this is a beaker containing water, and this is one molecule of water, and this is another molecule of water. So what will happen, one water molecule will donate proton to another water molecule, and it will going to form a hydronium ion. Okay, and here OH minus will be formed, which is known as hydroxide ion. So to form this one hydronium ion and one hydroxide ion, you require two water molecule. Okay, so to form a hydronium ion and hydroxide ion, you require two water molecules. This is the reaction. So you can say that means that two water molecule is used to give one molecule of hydronium ion and one hydroxide ion. Okay, so if you want to write in the reaction format, so this two water molecule, here we are writing two water molecule react with each other to form one molecule of hydronium. This, see here, this is hydronium ion, this is hydronium ion plus hydroxide ion. So instead of writing this reaction, you can write in similar fashion. What you will mix this two water molecule, you are going to form what? Two water molecule. So how to write the reaction? 2H2O gives one hydronium ion and one hydroxide ion. Okay. Expression for ionic product of water. So derive the ionic product of water. First we have to write the reaction. The ionization of the water can be represented as, so two molecule of water will give one hydronium ion and one hydroxide ion. Okay, so what equilibrium constant K for the ionization product of water, ionization of water is given by, so to find the K, so K will be equal to what? Product of the product. So what is the product here? Hydronium ion concentration and hydroxide ion, and you have to multiply these two. So multiplying this hydronium ion concentration and hydroxide ion concentration, divide by H2O molecule. So divide by what? H2O. But how many H2 is there? 2 H2 is there. So here you have to write H2O whole square. So this 2 came here on the upper subscript. Okay, next. So this is the formula we have derived. Now bring the water molecule on the left hand side. Okay, so this is equation number 1. So since the majority of the water molecule are undissociated, mostly the water dissociate to very small extent. So we mostly very small extent. So you can assume that water molecule is almost constant. It has dissociated very little. So K into H2O. H2O molecule is almost constant, so H2O concentration is almost constant, which can be represented as K dash. So instead of writing H2O whole square, we will write here K dash. So substituting the value, we will get K into K dash equal to H3O plus hydroxide ion, and two constant will form one more constant. So here K into K dash is equal to KW. What is KW? KW is ionic product of water. So instead of writing K into K dash, two constant form one more constant. So that constant is what? KW. So here we will write KW equal to H3O plus and OH minus, and this is the derivation we have to derive. This is the formula of ionic product of water.
pH of a solution may be defined as negative logarithm to the base 10 of the molar concentration of H plus ions in the solution. So mathematically, the pH of a solution can be expressed as pH is equal to the negative log to the base 10. There's a common log that we use, negative log to the base 10 of the molar concentration of H plus ions in the solution. The pH of a solution has a negative logarithm to the base 10 of the molar concentration of OH minus ions in the solution. So mathematical expression would be POH is equal to the negative log to the base 10 of the hydroxyl ion concentration.
Bunsen pH scale. Acidity, basicity and neutrality of the aqueous solution. This is the pure water. So in pure water, hydronium ion concentration and hydroxide concentration both are equal. Number of H3O plus and number of OH minus is always equal in water molecule when it is a pure water, and at what temperature? 25 degrees Celsius. Okay, and in aqueous neutral solution also the concentration of acid ion concentration, that is hydronium ion concentration, and hydroxide ion concentration both are equal in the neutral solution. So at 298 Kelvin. For pure water or in aqueous neutral solution at 298 Kelvin, always remember that H3O plus concentration and hydroxide ion concentration is always equal, and it is equal to what? 10 raised to minus 7 molarity. Okay, so always remember at 25 degrees Celsius or 298 Kelvin, hydronium concentration is 10 raised to minus 7, OH minus concentration also 10 raised to minus 7. So if you want to find the pH of this, the pH is equal to minus log to the base 10 to the H3O plus concentration. To find H3O, if I know that H3O plus concentration is what? 10 raised to minus 9. We will substitute the value here. So what we will going to get here? Minus log to the base 10. Instead of H3O plus, you can write 10 raised to minus 7 for a neutral solution. So here the answer will be what? Minus 7 will come here. Minus 7 into minus 1 is equal to what? Log to the base, rest you have to write the same thing, log to the base 10 into 10, and this value is 1, and this minus into minus will be 7. The answer will be 7 into 1, which is equal to 7. So pH is 7 for a neutral solution. Always remember, if the pH is 7, the solution is neutral. Next, acidic solution. If the solution is acidic, in an acidic solution, suppose this is a sulfuric acid, and you know that in a sulfuric acid hydronium ion concentration is more, so there is an excess of H3O plus ion. So you can see here hydronium ion concentration is greater, okay, as compared to OH minus concentration. OH minus is very less and H3O plus concentration is more. If H3O plus is more, it means the solution is acidic. Okay, so as in the diagram you can see H3O plus is greater than OH minus ion concentration. So this OH concentration is suppose 10 raised to minus 7. So you can assume that hydronium ion concentration is greater than 10 raised to minus 7. So Sorensen will have said that that if I bring this pH scale, in this pH scale you can see here there is some value here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 till 14. The pH value start from 0 and ends at 14. So here hydronium ion concentration is what? Greater than 10 raised to minus 7. What is greater than 10 raised to minus 7 means minus 6, minus 4, like that. So here this is the range for acidic solution. So less than 10 raised to minus 7 means what? Minus 6, minus 4, minus 4, minus 3, minus 2, minus 1, 0. So this part, if the H3O plus concentration is either 10 raised to minus 6, minus 4, 10 raised to minus 4, minus 3, 10 raised to minus 2, minus 1, or 10 raised to 0, then the solution will be acidic. If the concentration is in between 10 raised to 0 to 10 raised to minus 6, the solution will be acidic. It means there is a H3O plus concentration is greater. Okay, and pH value will be from what? 0 to 6. So always remember pH is always less than 7 if the solution is acidic. Okay, next basic solution. In basic solution there is an excess of OH minus ion concentration. Example NaOH. In NaOH, OH minus concentration is greater as compared to hydronium ion concentration. So now H3O plus is lesser than OH minus ion concentration. So it is less than what? H3O is less than 10 raised to minus 7. So in this pH value, see this is the pH scale, and here the hydronium ion concentration is in the range between what? 10 raised to less than 10 raised to minus 7 means what? 10 raised to minus 8, 10 raised to minus 9 to 10 raised to minus 14. So this is the range when the H3O plus concentration is 10 raised to minus in between 10 raised to minus 8 to 10 raised to minus 14. You can assume that this solution is basic in solution or alkaline. So this is the range. If the pH value is 8 to 12, 8, 9, 10, 11, 12, 13, 14, any of this pH, if we get the value of pH, then the solution will be alkaline. Okay, pH greater than 7 means a solution is basic in nature.
Thank you for watching this video. If you like this lesson, please like, share, and subscribe to Aklesh Sir AV. Click on the next video to continue learning. See you in the next class.